Welcome everyone to the next episode of Blocker or Fantastic Blockchain, completely from scratch, written in Go. Right, so I think in the previous lesson, what did we do? Let's do make run real quick to see what's going on here. Adding transactions. Yes, we're adding these blocks. We do some basic validation. The problem is we also need to do our transaction validation, and that's going to be a little bit nasty. We're probably going to spend some lessons on this because handling UTXOs and all that stuff, checking if it's unspent, is somewhat of a hassle. Right, so what we're going to do is we're going to open up chain. Actually, we're going to open up store real quick. Right, so we have our block store. We're also going to make a new store, and that's going to be a TX storer. Right, TX storer is fine. It's also going to be an interface, and we are going to basically do a put here, which is going to be a proto transaction. We're going to make this more efficient because we can make these efficient data structures and able to check if transactions are unspent and all that stuff. And if it's still a little bit confusing for you, no worries, we're going to cover that soon. I think we're going to return an error here, and then we're going to get a transaction based on its hash, which is going to return a proto transaction and of course an error. Right, I think that's a good TX storage. So let's make our type or memory thingy. We are going to say TX. No, it's going to be a memory TX store struct. Just like that. We're going to say here TXX is going to be a map of actually string, which is going to be the hash of the transaction into pointers of proto transaction, just like that. And then we're going to make a new one. Func new memory TX store. It's going to return as a pointer to this memory TX store, just like that. And we are going to return an memory TX store, and we're going to say that the TXX is going to be make me a map of string with proto transaction and call it a day. Because if we have a hash, it's very simple. We can actually query all the outputs basically. We can query all the outputs by just querying the transaction by hash and then returning the outputs, right? If they are spent or unspent, we need to check that by looping. We're gonna see. It's and we're probably gonna make it more efficient along the way. But let's make it simple first. You know, make it work, make it better, make it fast, right? So that's that. Perfectly fine. Now we're gonna make some stuff. We're gonna say func. It's gonna be as probably memory TX store put string. Actually, to be honest, no, we can do this, right? We're gonna put TX, which is gonna be proto transaction error, and we're gonna say that the hash. Let's do hash, please. Yes, it's gonna be hex encode to string the types hash transaction of this TX. And then we're going to say, actually, we need to lock here. Let's make a sync mutex, by the way. A lock is going to be a sync rw mutex because we need to make sure it's protected. Yeah. You know, distributed stuff. We need to make sure we lock that so we don't have any race conditions, data corruption and all that stuff. The hash is this. Then we're going to first of all, we're going to say as a lock. And we're going to lock for writing. It's going to be a lock defer as lock unlock, right? We're going to hash that stuff, and then we're going to say as TXX hash is going to be the TX, right? That's that. And we're going to return null because there are no errors. But hey, maybe in a database environment, if we have a real database, we probably going to return an error, right? But in our memory implementation, not, right? No coffee, that's so bad. All right, next thing is basically, let's copy this thing, let's paste it in, and we're going to say get here, get, and that's going to be a hash, which is going to be a string. We're going to return here a pointer to a proto transaction and an error. Just like that. We're gonna basically say s lock for reading, right? It's gonna be an R lock. And then we're gonna say defer as lock or unlock. Toppy. Then we're gonna say that the TX, man, I'm getting sick, not gonna lie, but it is what it is. The show must go on, right? It does not matter how you feel, you just need to make sure stuff is happening. So the TXR is going to be, not R, it's going to be OK, right? It's going to be an OK, and it's going to be S TXX of the hash. If not OK, right? If we don't find this transaction, we're going to say, we're going to return null fmt error f could not find tx with hash. This percentage s is going to be the hash here. Boom, call it a day. Otherwise, we're going to return the tx nil. Boom. Fine. All good, all good, all good. Right. Yes. So now, in chain, we're going to have a block store here, but we're also going to have a TX store, right? TX store is going to be an TX storer, right? And we need to do this like this. TX store, TXS basically is going to be good. TX storer. And we're going to say that the TX store is going to be the TXS. Actually, to be honest, I'm going to call this TX store. I don't like the variable naming here. Perfectly fine. Of course, right now in chain test, it's probably going to... What's going on is chain test. It's going to be, yes, here. Some problems here. We're going to say new TX memory store. Perfectly fine. Do the same thing here. Boom. Fine. And here, new memory. Fine. All right. Let's do a make test real quick to see if everything is Gucci. Boom. All perfectly sweet. And I think the light is a little bit too bright here. I can see it in my window. But hey, it is what it is sometimes. Glimming. Like a glimworm. How do you say that? Okay, what we're gonna do is we're gonna test this real quick, right? So we're gonna say here func test add block with transaction. With the x actually is fine, right? Gonna be t testing t hop 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 hop. We're gonna copy this chain thingy here. We're gonna paste that in. And then we're gonna actually say something. Let me copy some stuff. We're gonna block hash all that stuff. Let's copy this here, paste it in. We don't need a block hash. We have this block. We're gonna add that block. That's fine. Let's make a nice var encapsulation here. We're also gonna make a transaction, right? So that's gonna be a pain in the ass. So we're gonna say tx. We're gonna say inputs. It's gonna be a slice of proto. Takes input. We're gonna have outputs, right? Outputs. So basically the input of a transaction is going to be an output of a previous transaction. But we don't have that yet, right? We don't have that yet. So we're gonna do whatever we need to do to make this kind of work and to make this a simple test. Output is gonna be a TX output, just like that. The inputs is gonna be basically we don't have anything, right? In this case. Let's make a private key real quick. Private priv key is going to be crypto. Generate a private key, just like that. And then we're going to say here the public key. We can't, we need to do this. The public key of this input is going to be the priv key. Public bytes, right? That's the public key. What do we need? The pref index actually. Pref tx hash nothing, and the pref index is going to be 0 actually. Not really stuff to add. Later on it's going to be more clear. Outputs, that's another story. We're going to say this, the amount. We're going to send 100 whatever to address. We need to have a destination address. We're going to say the dest address, or recipient actually. Recipient is going to be crypto, generate a private key, we're going to say public, and then we're going to say address, and then we're going to say bytes here. Look at this. Boom. And then we're going to say the recipient. All good. That's the output. Then we're going to say tx is going to be n proto transaction, right? We're going to have a version. This version is going to be 1 for now. It doesn't really matter. We're going to say that the inputs, outputs. Look at this. Then we're going to say block transactions is going to be, can we append that? Block transactions. We're going to input this tx. It's going to be fine. We also need to sign the transaction. That's correct. We're not going to do that for now. Right. So then we're going to add the block. And what we want to do, we want to require real quick. What we want to require is, first of all, we're going to say that the tx, we're going to say that the fetched tx, right, is going to be chain tx store get me the hash of the transaction. We're going to say tx hash. What's going on here? Tx hash is going to be hex encode to string types hash transaction tx. Get me this tx hash, right? We're going to assert nil t r, and then we're going to say assert equal t the transaction we already have, and the fetch tx should be exactly the same. Right? Let's see if that works. Boom. We fail. Unrecognized shenanigans. Okay, cool. That's perfectly fine because we forgot something, right? Right now, in our chain here, we need to actually add that, right? So, validate block. If we verify the block, we're going to verify each transaction, which is still not the case. We're going to do that later on. We're also going to validate each transaction by checking if he can send that amount, if that's unspent and all that stuff. But that's also for later on. We are setting things up so we can do that. The next thing we're going to do is add the transaction. We're going to do here, add the block here. We're going to say for underscore tx in range all the transactions of this block. We are going to say c tx store put me this transaction. We have an error here, so we could say if r is going to be and the error is not nil, we are going to return that error just like that. To be honest, yes, that should be because we should do all our validation already, so that's fine. I think maybe we should, yeah, I think it's fine, perfectly fine. So now we can actually make test once again. Boom, and everything is working perfectly fine. That's good, that's amazing. Okay, so enable to make this transaction to test more stuff and to basically here to, in our inputs, we cannot specify a lot of stuff. We cannot specify. So basically, if you make a transaction, right? If I want to send 50 Bitcoins to somebody, I need to basically query the blockchain, query the database actually, and specify unspent outputs and use them as inputs into my new transaction. But because there is nothing, right? It's just a test. We don't have anything, so we cannot test. We cannot specify any output in our inputs because we don't have outputs, right? Man, it's not looking too good for me. So what we're gonna do is we go to Genesis. Actually, what I'm gonna do real quick is I'm gonna open up main, and I'm gonna make a seed. And you will see why I'm going to do that, right? I'm going to say the seed is going to be a crypto. No. We're going to say, going to be util, random, a hash, right? And I'm going to print out real quick. I'm going to print out hex encode to string this seed. And return. And I'm going to make run real quick. Boom. We're going to have the seed. I'm going to copy this. I'm going to chain search for my genesis. I'm going to say that the seed is going to be this. That's fine. Let's go to main real quick here and delete our code here. Right, chain. So I'm going to make a deterministic private key so we can have coins or some kind of a genesis input, basically output actually, that we can use as inputs in our transactions. If that makes sense. It will make sense. That's the seed. So what we're going to say here is the seed bytes. And we're going to, don't use the arrow here. We're going to say hex decode string. Decode string here. We're going to say seed. And then we're going to say generate a new private key from seed. This seed bytes. Boom. And now we're probably always going to have a deterministic private key. And what we're going to do is we are going to that's our block, that's our header. We're going to sign that block, that's fine. We're also going to make a transaction real quick. We're going to say tx is going to be n. A proto transaction is going to be the version. We don't actually care. It's going to be 1. It's good. We're going to say the inputs, right? We're going to make a cool input here. Actually, we're not going to make any inputs. We don't need inputs. We only need the output, right? Because we don't going to validate this. It's the genesis. We don't give a shit. We're going to mine, not mine. We're going to create tokens out of thin air. Isn't that amazing? That's crypto. You make tokens out of thin air, out of nothing. This is amazing. And that's exactly how it is. If you think, where are all these coins coming from? Well, from thin air. So we're going to say that this is going to be, and that's my favorite part of making blockchains. We are God, right? We are God. We are creating our own stuff. Proto takes input, right? No. Takes input, just like that. Boom, boom. Fine. It's going to be a slice. So actually, we're going to do this. The outputs is perfectly fine. So we're going to say outputs. So we're going to basically output this seed. So we can use that in our tests, actually. For now. So the outputs is going to be a slice of proto. TX output, right? And we're going to send that. How much are we going to send? Amount. No, we're going to say this. The amount is going to be, let's send, I don't know, 1,000 shenanigans, tokens, GG tokens, whatever. Hey, you name it. It's fine. And of course, we need to have an address, right? A destination. And we're going to say it's going to be the priv key. We generated bytes. No, not bytes. Priv key, public, address, bytes. Boom. That's our thing. Boom. That's the TX. Then we're going to say block up transactions is append block transactions TX hop. We sign the block. Of course, we also need a Merkle tree, a Merkle root of all the transactions inside of it and put it in the block so we can sign that. So we have a deterministic way. We need to do that, and I think it's going to be for the next episode because it's very, very important. Because if we open up our types proto, what do we have in block? We have a header, right? Here we have the root hash. It's the root hash we need to do, right? The Merkle root of the TX, very important because we need to hash that. Because we don't hash the transactions, we need to hash the root hash. We're going to do that pretty soon. Very importantos, right? Otherwise, we can tamper with these transactions and we don't want that. So that's our Genesis block. Let's open up chain test real quick, right? So test add block with TX. Actually, we could do test new chain real quick. Let's open up my chain. Can we do... I'm going to make a const here real quick, actually. Const seed is going to be this. I'm going to call this a god seed. For now, I'm going to delete that. Sure. For production, of course. Seed bytes. is a God seed. So we have a God seed we can always use, right? Oh man, right. So now, what we're gonna do here, the private key is not gonna be this one. It's gonna be the crypto new private key from seed. We need to do this. That's actually a nasty one. To be honest, what I'm gonna do real quick is I'm gonna do crypto keys here. I'm gonna make this a little bit better. New private key from string. Hey, we can do from string. That's crazy. Do we want that actually from string? Is it from string? I don't think that's a good, correct thingy. Let's open up keys real quick, because that's a decode string, and then we're gonna make this. Yeah, it's from seed here. I'm gonna do this. New private key from seed string. And that's gonna be a string. Right, and then we're gonna say seed bytes. What's going on here? Seed bytes. We can panic. Who cares? It's gonna be hex decode string. This seed. If R is not null, we're gonna panic this error. And then we're gonna return new private key from seed, this seed bytes in it, and call it a day, right? Then in chain, we can do here new private key from seed str, and that's gonna be the God seed. God seed, boom, delete this, should be fine. Oh man, insane stuff, right? And then we're gonna say here the priv key is new private key from seed str, and that's gonna be the God seed. Hop. Alright. So that's good, that's good, that's good. So what we're gonna do real quick is our inputs, we need to specify the previous output. And we need to make some convenience way to do that. This is gonna be nasty, but it is what it is sometimes. So we're gonna say the pref transaction, we don't know that. Maybe we should also make a mapping of... because look what we're gonna do. We're gonna do something very stupid, right? So we're gonna say... FTX is going to be, I'm going to do something very nasty. Chain. We can't, right? I have an idea. I have an idea. Chain. What we're going to do is create this Genesis block. We're going to return a block. It's going to add that block. Where is this? Okay, let's do this. fmt print ln new. What's going on here? New tx, right? And we're going to say and go to string types hash transaction this tx, and we're going to print that out, right? We go to, is it going to be the same thing? That's the question, right? Probably not. because it's probably going to be the same transaction, to be honest, the same hash. Chain test. Can I run this real quick? This is going to be that transaction. So I can do something like chain. I'm doing some nasty stuff, I'm gonna lie. Stain TX store get this guy. It's gonna be assert nil tr. And this FTX basically is FTX is gonna be so nasty. I'm gonna change that up. It's gonna be FTT. It doesn't matter, right? Fetch transaction. So I'm gonna fetch a transaction that we stored, because in that transaction there are my inputs, my outputs actually. My outputs I need to use for inputs, right? This is so complicated, but it is what it is. So let's do something like fmt println this ftt. Let's see if this is gonna work. Right, it's gonna be this, right? This is a transaction. This is my output, right? So we're gonna actually say here, the pref_tx hash. It's gonna be bytes, right? It's gonna be this one, the FTT hash, right? That's a and now we're gonna say the pref_tx out index is gonna be 0, right? What do we need? Proto. Pref hash, yeah, okay, signature, yeah, that's the last step we're gonna do. So that's this. But then there's gonna be a problem, right? Is we're gonna spend 100, but we're gonna have left, right? Because if this is gonna be spent, right? This output is a spent output. It's an unspent output. It's partially spent. What we're gonna do is we're gonna make another output, right? We're gonna make a change. So we're gonna say the amount is going to be we're gonna hardcode it for now. We know it's 1000, so it's gonna be 900, right? And the address is going to be our address. Which is our public key here. Actually, this is so nasty. We need. I remember this when I was doing Bitcoin stuff. It's so fucking nasty, man. We're gonna say private key public bytes. Right? So we're gonna send it back. No, it's not true. This is so bad. This needs to be an address bytes, right? Boom. So we're gonna send it back to our own. Right, so I think we have this set up, so we can do the validation in the next lesson, because otherwise it's gonna be too complex. Let me make make test actually. Boom, bam, it's working fine. Right, so what we do here is basically we have in our Genesis block we are sending money from nowhere to a God seed, right? Then we're gonna send from our God seed address to a recipient, right? And we're gonna send basically 100, right? But we have 1000, so we need to specify in our inputs, we need to specify the output from the genesis, which is basically 0. It's our public key, it's 0, and it's going to be this hash, right, of the previous transaction. Then we're going to spend an output. We're going to spend 100 to a recipient, and then we are basically going to make another transaction back to ourselves, right? So we have this. This is going to be spent, and this is going to be unspent later on, right? If you know what I mean. This we can use that back again as an input. We could use this as an input, but probably not, because this is going to be if this is getting used, we can't, because this address, well, we can't. You will see later on, right? Not make things complicated, right? So I think this is going to be a very good starting point to do a validation of our UTXOs. You see, it's already getting some complicated, and I try to make it as simple as possible, but a matter of fact, you need to play around with it because it is just hard to grasp. And that's the exact reason why I'm making this series, because with an UTXO model, because it's super important you understand that, because the holy grail of crypto Bitcoin is using that model, right? So yes, I see you in the next lesson.